Continuing on from our previous lecture, we are going to cover how to do a correlation analysis using SAS and other statistical tools. So we've already demonstrated the CORREL formula in Excel, which we can use to generate the correlation coefficient between two continuous variables. I will now introduce the PROC procedure correlation or the PROC CORR in SAS. The syntax is as given. PROC CORR data equal to data set name var v1 v2 run. So the correlation is always between two variables. Therefore, we need to specify the two variables between which we need to generate the correlation matrix. So I'm going to go to the SAS software now, and we're going to generate the correlation matrix or the correlation between read and write variables on the HSB2 dataset. So I'm going to paste the syntax. So it becomes proc core data equal to data set name. I'll replace with data.hsb2. Variable will be read and write. And that's all I need to do. I'll introduce the HTML ODS HTML over here. And there we have it. Select this, press F3. And there we get it, the procedure for PROC CORR. So when I do PROC CORR, I also get the summary statistics for the two variables. I get for each of the two variables, each of the variables, the number of observations, mean, standard deviation, sum of the whole column, minimum and maximum. And here I get the correlation matrix. So the way to read it is each cell we get the correlation between the row end and the column end. So correlation of a variable with itself will always be 1, because if you plot a variable with itself on a scatter diagram, you'll get a perfect line. So over here we have the correlation between read and write. Now the correlation between x and y and x is always the same thing. It doesn't matter. So the correlation between write and read is the same, and it comes out to be 0.59. So is that a strong correlation or not? So based on our previous lecture, we can see that it's about medium to strong correlation. And again, as I mentioned earlier, this is only a rule of thumb. This is not it's not laid down in stone, the interpretation of what is strong and what is weak. And more importantly, in SAS we also get the significance of the correlation. So over here we get a value of 0.001, and this is the p value over here. So as mentioned here, so this is the p value. So what is the sorry about that. So what is this p value? What is the test it is doing? So if you read this text over here, that gives us a hint. So we get the Pearson's correlation coefficient for the observations equal to 200 or a sample, and below this we get the H naught for the hypothesis test that has been carried out. The H naught is that rho is equal to 0. So this is similar to one sample t-test that we've performed, and we're testing the hypothesis whether the population correlation is 0 or not. So please understand that the R that we get is the sample correlation, because we're working with samples. So just because the sample correlation is 0.59 does not mean the population correlation is also 0.59. It could be something else. So the sample that we've extracted has got a correlation of 0.59 between the two variables. So what is likelihood of the population correlation between read and write to be 0? So how likely are we to get this correlation by chance or by accident, or due to the presence of a single outlier? So this is the hypothesis test that has been carried out, and we see that the p-value is much lower than alpha at 5%, so we can reject the null, and we can definitely say that the correlation between read and write is not 0, it's something else. So this is something which is not used very often, but typically if you have correlations close to 0.1 or 0.2, where you might be tempted to use that there is a very weak correlation over there, checking the significance of the correlation can make sense. For example, if the correlation between sales and advertisement is coming out to be positive 0.2, but before you start pumping money into the advertisement budget, if you see that the significance of the correlation is not there, or the p-value is greater than alpha, then you know that that correlation is coming due to a sampling error and it is not significantly different from 0. So it's used, not used very often, but it's always good to know, and we always check the p-value. If this p-value is greater than 0.05, then we can ignore the correlation coefficient that we get. It's either close to 0, and even if it's not close to 0, it's not significantly different from 0. Now supposing I want to generate the correlation between more variables in one shot, what we can do is we can start writing down all the variables in the var statement. We need not write separate procedures for generating correlation matrix for, or the correlation coefficient for between other pairs as well. So I'm going to write down all the variables: read, write, math, science, and social studies here itself. So math, science, social studies. So even though I've written all the variables in one shot, we don't get one correlation for 5 variables. We will get a correlation coefficient for every pair that we get. So this is where the correlation matrix comes into play. So if you look over here, we get a sort of a matrix where the diagonal is 1. So diagonal is always giving us the correlation between the same variable in itself. So between read and read, it's 1. Between write and write, math and math, science, and then social studies. Now the correlation matrix above the diagonal is going to be a mirror image of the correlations below the diagonal. For example, the correlation between read and write is 0.59. The correlation between write and read is again 0.59. Similarly, the correlation between social studies and read is 0.62. And I look over here, between read and social studies, it's 0.62. So I generate this correlation matrix in one shot, and I'll be able to generate the correlation of all the variables over here. And this is actually very helpful if I want to look at the correlation of multiple variables. So I don't have to write multiple procedures and needlessly run or execute it multiple times. So we can generate the correlation matrix of all continuous variables in a dataset in one shot. So we have the correlation matrix on SAS over here. Let's move on to generating the correlation matrix on SPSS. On SPSS, we'll go to Analyze, and there is a let's look at descriptive stats. No, sorry. And there's an option called Correlate itself over here, and there we have it. So on Correlate, we'll use bivariate because we are doing bivariate correlations, Karl Pearson's bivariate correlation. And I will select all the variables in one shot, press them over here, and it's already mentioned, clicked on Pearson's coefficient, and let's click on Spearman as well. So we will generate two correlation coefficients. The test of significance is two-tailed, and it will automatically flag significant correlations. And in the options, there's nothing that we want to change over here. That's it. So press OK, and there we have it. So we generate the correlation coefficient, so Pearson's correlations for all the variables. Again, this is going to be a mirror image above and below the diagonal, and the correlation will be exactly the same as they have been generated on SAS. So this is the Karl Pearson's coefficient, and if we look at the non-parametric, which is the Spearman coefficient, so here we get the Spearman's coefficient of correlation as well. So as mentioned earlier, Spearman is nothing but Karl Pearson on ranks. So in most cases, you will see that the Spearman's coefficient is slightly lower than Karl Pearson's in most cases, but not necessarily. So I skipped demonstrating how to generate the Spearman on SAS. So for generating the Spearman's coefficient, the procedure is the same, the syntax is the same, except in the first statement, we simply type in Spearman. Now if I select this and execute it, I will get the Spearman's coefficient of correlation. So here's the Spearman's coefficient of correlation in SAS as well. So we've demonstrated the coefficient generating the correlation on SPSS, and let's move on to Statistica. So we have the previous results open. I'll close them. So here we have the data sets. Let's go to statistics, and let's look at the various options that we have: basic statistics and tables. and there we have the correlation matrix as an option directly. Press OK, and let's have a select. So here we can select the variables for which we need to generate the correlation matrix. So I will select all these variables in one shot. Press OK, click on summary correlations, and there we have it. All the correlations have been generated, and it automatically executes a significance test, and all the correlation where the p-value is less than alpha at 0.05 is marked with the red font. So all the correlations are coming up as significant over here. So we see that all subjects are positively correlated amongst each other, i.e. you score well in one subject, you're likely to score well in all the other subjects as well, and vice versa. And if we look at Statistica, we also get a few other options which are very powerful. For example, I mentioned earlier that if we are working with a dataset which we are not familiar with, just looking at correlations is going to be problematic, because there might be outliers which inflate the correlation value. And I had demonstrated how even one outlier can make a correlation from 0 to 0.85 just by changing one observation. So it's always a good idea to generate these scatter diagrams. And in Statistica, we get this option called Scatterplot matrix for all selected variables. If I click this, I can select all the variables, press OK, and I get a very nice scatter diagram of all variables with itself. For example, over here, for this particular scatter diagram, this is the scatter plot between read and math over here. So this scatter diagram on which I'm pointing right now is the scatter diagram between read and math. So you have to look at the intersection over. So if I select this, so this is the scatter diagram between read and science. So I can visually look at all the scatter diagrams, and it automatically tells me which correlations are more stronger than the others. And if there is an outliers present, so outliers can be seen visually in a scatter plot as well. And I can see in all the scattered plots, there doesn't seem to be any strong outlier or any blatant outlier as such. So this scatter diagram in the correlation option in Statistica is extremely helpful. Of course, if you want to generate scatter diagrams in SPSS, it's very simple as well. So go to Graphs, Chart Builder, and let's select the scatter diagram option over here. So we get the scatter dot. So this is scatter diagram, and I want to generate the scatter diagram between. So let me select scatter diagram here. I want to generate the scatter diagram between write and read. And that's it. I press OK. Go to the output, and there SAS SPSS has generated the scatter diagram automatically for me, and I can now study the scatter diagram and check for outliers if any. In SAS, generating the scatter diagram, you'll have to use either the ggplot procedure, or on Enterprise Miner, it is actually again a graphical procedure. So we won't cover the ggplot in SAS. For that, I would suggest looking at our SAS-based SAS modules. So this was how we've generated the correlation matrix across SAS, SPSS, Statistica. I'm now going to demonstrate how to do it on R. So let me pull up an open R right now, and I'm going to execute Rattle. So library, Rattle, and then open Rattle. So SP on Rattle also we have a lot of in fact some very good graphical functions which generate the correlation matrix. I'm quickly going to import the dataset HSB2. So let's have a look. E drive tutorials, and there it is, HSB2. Generate it in. We don't need to select any of the nominal variables. I'll only select the variables read, write, math, science, social studies. I don't need to partition data. Press execute. And there in the explore options, there's an option or a radio button called correlation. You can click on it, and we select Pearson. So you can select Spearman over here as well, but we'll select Pearson for now, and simply press execute. It's asking me to install a package, so let me just install the package automatically. and there we get it. So we have the correlations generated over here. Now the way to look at this is the darker the darker and more sorry the darker the color, the stronger the correlation, and this direction shows us that this ellipse is a direct correlation. In case the direction of this ellipse is tilted towards the left hand side, in that case it's an inverse correlation. So we get the correlation matrix as well. So this is similar to the text matrix that we get in all the other tools. But this graph is very useful also because we can visually see which correlations are stronger as compared to the others. So if you get a flattish looking ellipse, that's not as strong a correlation. If you get a very dark looking and a thinner ellipse, that is indicative of a stronger correlation. So while this is good at a glance, you would still want to look at the actual raw values, and the raw values get generated over here in the Rattle output. If I want to look at Spearman's correlation, simply select Spearman, press execute, and look at the data again, and we get the Spearman's correlation. So very easy to generate correlation matrices as well. Finally, on Excel, till now we have been using the Correl formula, but if I want to generate the correlation matrix, there's a very simple procedure. I go to the data analysis toolpack, and there's an option called correlation over here. Press OK, and we will select all the variables for which we want to generate the correlation. These variables must be stacked next to each other if you want to generate the correlation matrix. Labels in first row, new output, press OK, and we get the correlation matrix for Excel as well. We only get the lower part of the diagonal. We don't get the correlation values in the upper part, but that's basically redundant because it's only a copy, or it's a mirror image. So in Excel also I can generate the correlations between all the variables in one shot. There is only one drawback in Excel, that the variables for which I'm generating the correlation matrix have to be next to each other, because can make only one selection in the option in data analysis toolpack. So we've covered generating the correlation matrix across all the procedures, and the only difference in Excel and the others is that in Excel we don't get the p-value, whereas the dedicated statistical tools do generate the p-value when we calculate the correlation matrix. The p-value essentially is testing whether the population correlation is 0 or not, whatever is be the sample correlation. That is all. Alright, so moving on. So we've generated the correlation on HSB2 dataset. For the car sales data now, test the correlation between all factors such as mileage, horsepower, wheelbase, etc. with price. Identify the variable which has the strongest relationship with price. So this is an exercise. So these two exercises I leave it for the students to continue with. The procedure is the same. We have to open the car sales dataset. So in fact, I'll quickly generate this on the data analysis toolpack. So on the car sales data, we have to test the correlation of all the factors with price. So we've got price over here. So I'll quickly copy it into a different tab so that we can do it quickly. We can do it on the data analysis toolpack, and we get all the other the variables over here. And let's have a look at the correlation matrix. So let's generate it over here. So there we have it. Labels in first row, press OK. So here are the correlations with price. As you can see, the highest, so we have one negative correlation. So higher the mileage, lower is the price, which makes sense because typically higher the mileage of the car, smaller is the car, and the cheaper is the car. So we've got one negative correlation. Wheelbase doesn't seem to be very strongly correlated. The strongest correlation with price comes out to be horsepower. That means stronger the car, more higher is the price. That also makes sense. So what I would ask you to do is to generate this correlation matrix using all the other tools that we've covered. So generated using SAS, SPSS, Statistica, and Rattle as well, and study the output. And more specifically, also look at the p-values. Make sure that the correlations on which we are basing our arguments are significant. That is, the p-value is lower than alpha. So that is all in this particular lecture. We'll move on to simple linear regression in our next lecture.